Uni-vent Eagle portable ventilation system. Incredibly small, incredibly light, incredibly powerful. Unlike anything you've ever seen before, the Eagle is an engineering marvel that adds to the Uni-vent list of accomplishments. The Eagle is the smallest and lightest ventilator ever developed for critical care. Weighing less than 13 pounds, the Eagle contains a compressor and air oxygen mixer, internal PEEP, a graphics display, automatic altitude compensation and LCD backlighting, powerful monitors and alarms, apnea backup, an interactive demo teaching mode, a secondary backup ventilator, and a fast startup sequence that allows you to begin operation in as few as 3 steps. The Eagle's development began after user requests for a self-contained ventilator were studied, and new technology based on Impact's ultralight compressor made the project's successful outcome possible. However, development went further to include operational simplicity, unparalleled patient safety and performance, and a coherent graphics display of patient data and device status. Many of the Eagle's features and performance have only been found in ventilators more than twice its size, weight, and costing much more. And until now, some of Eagle's features did not exist in ventilators regardless of their size, weight, and cost. The Eagle has many features that maximize patient safety and ease of operation. These features include operation from internal compressor, built-in backup ventilator, internal air oxygen mixer, external air and oxygen inputs, automatic altitude compensation, EMI, RFI, and aeromedical certification, interactive user demonstration mode, automatic backlighting of LCD display for viewing under any condition, management of available gas or gases to assure that the set tidal volume is always delivered, internal PEEP, which eliminates the need for external PEEP valves, low-cost disposable ventilator circuits, apnea backup mode, AC-DC rechargeable battery, airway pressure waveform graphics, and continuous display of all control settings. As you can see by these many features, the Uni-vent Eagle is perfect for emergency rooms, medical transport, ICU and CCU, aeromedicine, recovery room, SNFs, home care, personal mobility, emergency centers, and subacute care facilities. Once in a while, you see it happen. A technically superior product comes along and excels way beyond that of its competition. The Uni-vent Eagle is just that product. A portable ventilator that challenges the limits to provide better quality patient care. Let's take a look at the ventilator's front panel and review its controls, their functions, and its indicators. The first set of controls we'll discuss are the primary controls. They're numbered 1 through 5 on the panel and determine the operating mode, its characteristics, and percentage of oxygen delivered. The mode selector switch is the control numbered 1. It applies operating power to the ventilator for assist control, AC, synchronized intermittent mandatory ventilation, SIMV, continuous positive airway pressure, CPAP, or transducer calibration, CAL. The mode indicator displays the current setting of the mode selector switch. The VMIN indicator displays minute volume in liters in the AC mode. The ventilation rate control is the control number 2. It sets the mechanical ventilation rate for AC or SIMV. Its Its range is 1 to 150 breaths per minute, or BPM, based on the control position, and its value is displayed in the LCD above this control. The inspiration time, i.e. ratio control, is the control numbered 3. It sets the inspiratory duration for all ventilator-assisted breaths. Its usable range is limited by the ventilation rate control setting, and inverse IE settings are not permitted. Depending on the ventilation rate control setting, inspiration time range is 0.1 to 3.0 seconds maximum, which is based on the current control position. Both inspiration time and IE ratio are displayed in the LCD above this control. A fixed 1 to 2 IE ratio is provided at the fully counterclockwise position. The inspiration-exhalation indicator alternately displays the inspiration and exhalation phase of mechanical and/or spontaneous breaths. The tidal volume control is the control numbered 4 and sets the tidal volume. Its range is based on gas flow not exceeding 60 LPM or 1,000 milliliters a second as determined by the control position. Both set and delivered tidal volume are alternately displayed in the LCD above this control. The air-oxygen mixer control is the control numbered 5. It sets FiO2 when the ventilator is connected to external 50 psi oxygen and operates with the internal compressor or external 50 psi compressed air. Its range is 21 to 100% based on the control position, and the FiO2 value is displayed in the LCD above this control. The high-pressure alarm peak inspiratory pressure relief control sets a threshold value for the high-pressure alarm and peak inspiratory pressure relief. Its range is 15 to 100 centimeters of water based on the control position, and activates when inspiratory pressure exceeds the set point at any time during 4 consecutive ventilations. Its value is displayed in the LCD beneath this control. The high airway pressure alarm set point indicator shows the current setting of the high pressure alarm control. It is displayed adjacent to the digital bar graph. The low pressure alarm control sets a threshold value for the low pressure alarm. Its range is 0 to 50 centimeters of water based on the control position, and activates when inspiratory pressure does not exceed the set point at any time during 2 consecutive ventilations. Its value is displayed in the LCD beneath this control. The low airway pressure alarm set point indicator shows the current setting of the low pressure alarm control. It is displayed adjacent to the digital bar graph. The PEEP off-on set push-button switch adjusts the internally generated PEEP set point. Its default value is off and increases by 1 centimeter of water each time the push button is pressed. Its range is from 0 to 20 centimeters of water, and the set value is displayed in the LCD beneath the push button switch. The SI off-on push button switch has a default value of off. When set to on, the first breath delivered is a sigh. Each sigh breath is 150% of the inspiration time setting, which increases delivered volume by 50%. The sigh breath is repeated once every 100 breaths or 7 minutes thereafter, whichever occurs first. Sigh status, off or on, is displayed in the LCD beneath this push button switch. Sigh is disabled when pressure plateau is on. The pressure plateau off-on push-button switch has a default value of off. When pressed to on, the plateau value is automatically referenced 10 centimeters of water less than the high-pressure alarm peak inspiratory pressure relief control set point. The plateau range is 5 to 90 centimeters of water, and its value is displayed in the LCD beneath the push-button switch. Pressure plateau is disabled when sigh is on. The peak and mean airway pressure indicator continuously displays the peak and mean airway pressure of the previous breath. The digital bar graph indicator provides a continuous display of airway pressure. Its display range is from -10 to +100 centimeters of water, and its vertical resolution is 2 centimeters of water bar. The airway pressure indicator is a graphic display of the most recent 12 seconds of airway pressure information. Its vertical axis is calibrated with the adjacent digital bar graph. Its horizontal axis is calibrated in 1-second intervals. The Power Information Center is a two-line area that displays the current status of external power, internal power, and fuses. If the ventilator is not connected to an external power source, the XT PWR line is blank. The charge indicator, a green LED, illuminates when battery recharging current is flowing and turns off when the internal battery has fully charged. The external air off-on push-button switch is used with a nominal 50 psi compressed air source. Its default value is off, and its current status is displayed in the LCD beneath this push-button switch. The manual breath trigger delivers a manual breath equal to 1 complete ventilatory cycle at current settings in the AC and SIMV modes. In CPAP, the manual breath delivers gas at a 30 LPM flow rate for 1.67 seconds and is pressure limited to 40 centimeters of water. The manual trigger is operational when a system failure has occurred. Gas will flow at a rate of 30 LPM and is pressure limited to 40 centimeters of water for as long as the push-button switch is pressed. The Alarm Message Center, AMC, a centralized location for displaying up to 4 lines of alarm message information. Up to 2 alarms with a short message may be displayed simultaneously. If more than 2 alarms occur simultaneously, only the name of each alarm is displayed. Battery, low fail. Recharge, replace battery pack. External power. Check power source, connections. O2, low fail. Check oxygen source, connections. External air, low fail. Check air source, connections. Low pressure. Peak inspiratory pressure, too low. Disconnect. Check circuit connections. High pressure. Peak inspiratory pressure, too high. Apnea. Check patient for spontaneous breathing. Apnea. CPAP average rate less than 6 BPM. High PEEP. Inspiration began before end pressure plateau. FiO2. Gas mix error. Check source, settings, connections. Pressure alarm settings. Alarm settings reversed. VT. Delivered tidal volume does not equal set tidal volume. Comp. Compressor output, low fail. Inspiration time truncated to 3 seconds. Note I time and IE. Plateau volume. Delivered volume less than set volume. VT settings. I time flow, unable to deliver set volume. External power fail. Disconnect. Check power source. Connections. Inverse IE. Inspiratory time longer than exhalation time. Transducer calibration. Calibrate transducer. Transducer calibration abort. Recalibrate transducer. The following alarm overrides any of the previous messages when activated. Ventilator failure detected. This alarm message is followed by one of the following statements. Failure code 1. Self-check failure. Failure code 2. No gas and compressor failure. Failure code 3. Total flow backup. Check failure. Failure code 4, excessive airway pressure. Failure code 5, memory check failure. Failure code 6, exhalation valve failure. Failure code 7, excessive negative pressure. The alarm indicator is a red LED that flashes on-off when an alarm is not muted, stays on continuously when the alarm has been muted, and is accompanied by a pulsing tone that is canceled during alarm mute periods. It activates for all alarm conditions except a system failure alarm. The alarm mute cancel push button switch will mute an audible operating alarm signal, or cancel an advisory alarm signal, or cancel specific alarms such as apnea or external power fail. A typical mute lasts for 30 seconds. However, battery and power alarms are muted for longer periods. The system failure indicator, a red LED, illuminates continuously and is accompanied by a continuous audible tone that cannot be muted. It activates when the CPU is forced to stop operation, or a CPU failure has occurred and causes the LCD to blank. The first thing we will do before operating this device is connect all tubing, hoses, and cables. Our choice of gas or gases and operating power determines which hoses and accessories are required. If our use includes external oxygen or external air, remember to use only compressed gas that is rated medical grade. The ventilator contains fittings marked oxygen in and air in. In this case, we'll operate using external oxygen. Each fitting is sized in accordance with diameter index safety system dimensions, which are keyed and threaded for connection to a particular gas type. Color-coded hoses are provided with the ventilator. They attach to these fittings. Connect the oxygen hose provided, color-coded green, directly to the oxygen in fitting and its other end to a 50 psi oxygen source. This demonstration of operation does not use external air. However, if we were, the yellow-colored hose provided would connect from the air in fitting to a 50 psi air source. The disposable ventilator circuit consists of several hoses, an exhalation valve assembly, and a patient connector. The large 22mm hose provides gas from the ventilator to the patient. It connects to the ventilator fitting labeled gas out to patient. Small diameter translucent hose provides controlling gas from the ventilator to the disposable ventilator circuit exhalation valve. It connects to the ventilator's clear, uncolored aluminum hose barb labeled exhalation valve. A small diameter green hose is used to monitor pressure signals near the patient's airway. It connects to the ventilator's green hose barb labeled transducer. The patient connector is a small elbow. It connects to the exhalation valve via a short 22mm tube at one end and the patient's endotracheal tube at the other end. We've attached the ventilator circuit tubing and the oxygen hose. Now we will connect the external power supply. The external power supply has a black AC line cord which directly connects to AC mains rated between 90 and 260 volts. Voltage and line frequency are automatically sensed in the power supply. A gray output cable connects to the ventilator's external power jack. The external power supply includes a 9-pin sub-D female RS-232C connector which provides a communications interface for monitoring ventilator switch and control settings, alarms, and pressure signals. A mounting bracket interface on the rear allows attachment to an optional cart, wall mount, pole mount, or the ventilator itself. To electrically connect the external power supply to the ventilator, jack and plug must align to assure correct pin contact. A red dot on the plug aligns to a notch in the jack and allows plug insertion with minimal force. The plug is not removable from the jack unless you place its collar between your fingers and pull back. This outward force unlocks the jack and plug. A spring-loaded door protects the connector from dirt and dust when it is not being used. A 12-volt DC power cable is also provided with your ventilator. One end connects into a standard automotive-type cigarette lighter receptacle. The other end is identical to the output plug of the AC power supply. Alignment, connection, and removal from the ventilator's external power connector is the same. To begin operation, unlock the clear hinged door by turning the locking knob counterclockwise, allowing the door to open. Look at the current position of each adjustable control. Determine whether or not any of the presettings need changing. For example, inspiration time, i.e. ratio, and air-oxygen mixer. Do you want to customize certain settings? If so, you must access the User Program menu before operation. To access this menu, simultaneously press the Alarm Mute Cancel push button and the Manual Breath Trigger push button while turning the Mode Select switch to any position except off. The LCD screen displays User Program's information and directions. The external air, sigh, PEEP, and pressure plateau push buttons have temporarily become soft keys, which are now used for decision-making in conjunction with directives appearing along the top line of the LCD. By pressing the push button above the word PROG, Program, we can scroll through each menu. At the bottom of each menu is information that indicates the number of cumulative hours of operation and cumulative days since the last preventive maintenance was performed, the software version contained within your ventilator. The first menu allows you to set the LCD backlight threshold. The threshold represents the lighting level that will cause the LCD to illuminate. Follow the instructions. If you want to reset the threshold, press the push button above the word Save. If you wish to exit the menu, press the push button above the word Exit. The next menu allows us to set LCD contrast between activated characters and their background. We can adjust contrast upwards or downwards. The next menu allows us to temporarily change trigger level sensitivity, which controls the inspiratory work of breathing set point for patient-triggered breaths. This temporary change is for the current operating sequence only. When power is turned off, the normal default value will be restored the next time power is turned on. We can also lower the spontaneous flow for use in SIMV and CPAP on smaller patients. It too is a temporary setting for the current operating sequence and reverts to its default value when power is turned off and then on. The next menu allows us to operate in a demonstration mode for user training. It is interactive, and the only functions that are rendered inoperable are the transducer pressure sensor and the disconnect alarm. On-screen waveforms are simulated. A ventilator circuit may be used, but is not necessary. Do not use a test lung with the demo mode. The last menu allows us to test the backup ventilator. A failure of the primary CPU would cause the backup ventilator to operate. This menu feature allows us to verify its functionality. When you have finished making changes in the User Programs menus, press Exit. This allows operation to begin in accordance with current control and switch settings. After leaving the User Programs, operation can begin. Do this by exiting User Programs, which puts us directly into the selected operating mode. Alternatively, if we have powered off, which cancels any temporary settings made earlier, we can select any one of the 3 operating modes to begin. In this case, we selected the Assist Control mode. Turning power on causes the unit to perform a self-check. This process checks power, battery, memory, control panel settings, and transducer calibration. It normally takes about 2 or 3 seconds to perform, and then operation is allowed to begin. Do not connect the ventilator circuit to the patient until self-check completes. This prevents any pressure from entering the ventilator circuit and causing a false transducer calibration alarm. The front panel contains 5 numbered controls: the mode select switch, the ventilation rate control, the inspiration time, i.e. ratio control, the tidal volume control, and the air oxygen mixer control. The normal sequence of operation contains 5 steps. This means that a minimum number of control adjustments must be made to begin operation: 1, 2, 3, 4, and 5. The settings for controls 2, 3, 4, and 5 are displayed immediately above each control on the LCD panel. The setting for each push button and control located above the LCD is displayed across the top line of the LCD. To begin operation, set the operating mode, the ventilator rate, the inspiration time, i.e. ratio, set tidal volume, and then the air oxygen mixer. Because oxygen is connected, our air oxygen mixer range can be set anywhere between 21 and 100%. If oxygen was not connected, disconnected, or if our oxygen cylinder was empty, turning this control would trigger an oxygen alarm at all settings greater than 21%. We can cancel this alarm by returning the control set point to 21%. Verify all control settings to ensure their accuracy. By now, you will have noticed that the ventilator has begun cycling and that a disconnect alarm has occurred. Connect the ventilator circuit to the patient, which will cause this alarm to self-cancel. Verify patient chest rise and fall and confirm that any pre-existing low and high airway pressure alarm set points were not set too low or too high. You will notice the display of additional information on the LCD. The assist control operating mode is displayed, as is the calculation of delivered minute volume, which in this case is 9.9 liters per minute. And a display line which toggles between inhalation and exhalation denotes what part of the ventilatory cycle is active. Pressure waveforms and measurements are relative to the amount of pressure within the ventilator circuit. If we increase tidal volume, it will also increase the pressure waveform amplitude and measured values. The pressure waveform is a continuously moving 12-second display and corresponds to values shown on the adjacent digital bar graph. Peak pressure and mean airway pressure are displayed above the digital bar graph and update after each inspiration cycle. After setting the 5 primary controls, you may decide to use other operating features. Secondary controls have automatic or standard defaults. Others are adjustable. You can add PEEP, set low and or high pressure alarm limits, use external, air, or select operation with sigh or pressure plateau. Setting PEEP is simply a matter of pressing the push button, which causes the PEEP value to increase each time the push button is pressed. As PEEP develops within the ventilator circuit, the LCD waveform and digital bar graph display this remaining positive pressure. Do not attach an external PEEP valve. PEEP is generated internally using software control of hardware. To eliminate PEEP, repeatedly press the push button switch. PEEP is adjustable to 20 centimeters of water, then returns to 0. The low and high pressure alarm limits can be quickly set. First, make note of the peak airway pressure displayed above the digital bar graph. Next, set the low and high airway pressure alarm controls to values lower and higher than the displayed peak airway pressure. Another way to set the alarm limits is by observing the digital bar graph. 2 small bars or ticks appear to its right. These ticks correspond to the current low and high airway pressure alarm control set points and move upwards or downwards as their respective control is turned. Notice the tick movement as I adjust each control upwards or downwards within a safe proximity on either side of the peak airway pressure. In this case, peak airway pressure is 27 centimeters of water. The high pressure alarm limit is set for 39 and our low pressure alarm limit is set for 21. If the patient's peak airway pressure exceeds the high pressure alarm set point at any time for 4 consecutive breaths, it will trigger the high pressure alarm. If it stays below the low pressure alarm set point for 2 consecutive breaths, it will trigger the low pressure alarm. This virtually eliminates nuisance alarms by requiring 4 consecutive high pressure alarm set point violations and 2 consecutive low pressure alarm set point violations to trigger their respective alarms. You might ask, what happens if the patient coughs or exceeds the peak inspiratory pressure relief limit during 1 breath or 2 or 3 consecutive breaths? How is the patient protected? The peak inspiratory pressure relief mechanism activates at the high pressure alarm control set point, which momentarily opens the ventilator circuit exhalation valve and dumps excess pressure to atmosphere. So, your patient is protected during each breath while the high pressure alarm is disabled until 4 consecutive breaths have been violated. The ventilator will automatically operate from external air if 50 psi external air is connected when the ventilator is turned on. External air is connected by attaching the yellow air hose provided to the fitting labeled air in and a 50 psi medical grade air source. If external air is connected during operation, it may be utilized by pressing the external air push button to on. If you try to turn external air on and none is connected, it will trigger the external air low fail alarm. There is no way to eliminate this alarm except by pressing the external air push button to off or by connecting external air having sufficient pressure. If we want to use sigh, press its push button to on. A sigh breath is 150% longer than the inspiration time setting. It is delivered once every 7 minutes or 100 breaths, whichever occurs first. As soon as you press the sigh push button to on, the first breath delivered will be a sigh. A sigh breath cannot last for more than 3 seconds. It appears on the display as a longer breath with higher amplitude and is distinguishable from a normal breath. If a sigh breath exceeds the high pressure alarm set point, its peak will be clipped for safety purposes. Conversely, if you set the high pressure alarm set point to a higher value and then press sigh off and then back on again, a greater volume is delivered because peak inspiratory pressure relief does not occur. Pressure plateau is automatically referenced to the high pressure peak inspiratory pressure relief control set point. Pressing the push button sets plateau to on and establishes a pressure plateau that is always 10 centimeters of water less than the high pressure alarm control set point. In this case, pressing plateau on has no effect because the peak airway pressure is only 26 or 27 centimeters of water, which is less than the plateau value. If you lower the peak inspiratory pressure relief set point, it will cause truncation of the delivered tidal volume and chops the top from the waveform. This will also trigger a plateau volume advisory alarm. The advisory alarm indicates that delivered tidal volume is now less than set tidal volume because we've limited how much pressure is allowed each breath. Pressing the alarm mute cancel push button cancels the audible plateau volume advisory alarm, turns the alarm LED off, but allows the alarm message to remain so that anybody who looks at the screen will know that the ventilator is delivering less volume than it was set to deliver. We can cancel pressure plateau by pressing the push button to off. This cancels the remaining advisory message and returns us to our normal pressure waveform. The manual breath trigger push button has 2 functions. During normal ventilator operation, an additional measured breath is delivered at the current settings each time you press the push button. You can hyperventilate a patient by pressing this button or let the normal pre-existing ventilation rate resume. If there is a malfunction of the ventilator and the secondary or backup ventilator turns on, this push button becomes a manual trigger. It will allow gas to flow for as long as I press the push button. Gas flow to the patient is limited to 30 LPM and pressure limited to 40 centimeters of water. To calibrate the internal pressure transducer, turn the mode select switch to the cal position. The LCD display message will tell you to wait. When calibration is finished, the message tells you calibration OK. Turn the mode select switch to any operating mode to begin operation. Assist control delivers a combination of assisted and controlled breaths. The rate setting is a default setting that assures your patient will receive the minimum number of ventilator-generated breaths selected. If the patient is spontaneously breathing at a rate greater than the default setting, the ventilator will synchronize to each spontaneous effort and deliver a breath in accordance with the inspiration time and tidal volume control settings. In the SIMV mode, the ventilation rate is also the default rate. The patient is allowed to breathe spontaneously and assume the entire work of breathing between mandatory breaths generated at the default rate. For example, if the patient is receiving 6 mandatory ventilations per minute while spontaneously breathing at a rate of 12 breaths per minute, then 6 of the breaths will be assisted and the other 6 will be spontaneous, with the patient assuming the entire work of breathing. In the CPAP mode, the patient does all of the work of breathing, all of the time, and is subject only to the set air-oxygen mix and PEEP. If the patient does not breathe within 10 seconds, 6 breaths per minute rate, in the CPAP mode, an apnea alarm and operating backup mode are activated. The patient starts receiving controlled ventilations at a rate of 12 breaths per minute. When apnea occurs in CPAP, default values for ventilation rate, inspiratory time, gas flow, and maximum peak inspiratory pressure are invoked. Default values protect the patient because the ventilator cannot tell whether the patient is an adult, child, or infant. When apnea occurs in the assist control or SIMV modes, ventilator-generated breaths equal the current inspiratory time and tidal volume control values set by the operator. Battery change is quite easy. First, unlock the 2 battery compartment door locks and open the compartment door. Separate the mated halves of the 2-conductor automotive connector, then release the Velcro D-ring strap. The battery pack can be lifted and removed from its compartment. Place a new battery pack into the compartment. Use the D-ring strap to secure it in place. Make sure it is installed securely, then connect the halves of the automotive-style connector. Position the connector wires to lay flat. Then close the compartment door and secure its 2 locks. The Uni-vent Eagle Model 754 may be quickly and easily adapted for use in military aircraft such as the C-130, C-141, C-17, and C-9. Its optional mounting bracket attaches to stanchions ranging from 2 to 4 inches wide. The universal AC power supply with DC to DC converter, standard with all Model 754Ms, has separate auto-sensing inputs for use with 105 to 245 volts AC, 50 to 400 Hertz, or 16 to 30 volts DC negative ground. It may be secured with a tie-down to the stanchion or aircraft floor, or quickly mounted to an optional stanchion bracket. The stanchion mounting bracket attaches between parallel mounting surfaces by turning its thumb knob clockwise until a tight fit is obtained. The front surface of the stanchion mounting bracket includes a guide that interfaces with a mating dovetail molded into Eagle's lower case. Carefully slide Eagle's dovetail into the stanchion mounting bracket guide. A dovetail on the universal AC power supply with DC to DC converter allows for similar attachment to the stanchion mounting bracket. Hoses connect to fittings on Eagle's connector panel. Each fitting is labeled. If external 50 psi medical grade gases are used, connect their diameter index safety system, DISS, hoses to the fittings marked oxygen in and air in, respectively. The oxygen hose is color-coded green. The air hose is color-coded yellow. Carefully connect each of the 3 ventilator circuit hoses. The 22 millimeter hose attaches to the large fitting labeled gas out to patient. And the clear hose attaches to the hose barb fitting labeled exhalation valve. The green hose attaches to the hose barb fitting labeled transducer. The universal AC power supply with DC to DC converter has a keyed output connector plug. A red dot on this plug is used to simplify alignment with Eagle's power jack, which is located adjacent to the connector panel. A spring-held door with seal protects the power jack when it is not being used. It has a red dot and/or small keyway, which aligns with the output connector plug's red dot. Connect the universal AC power supply with DC to DC converter to the Eagle. Carefully align the red dots, then push the plug into the jack. The plug contains a knurled, spring-loaded collar which locks the plug and jack when mated. To release the plug, draw back on the collar and pull. Connect the power supply to a live AC mains. Open Eagle's front door, set its controls for operation in accordance with the operation manual, then connect ventilator circuit to patient. This training video tutorial may be used in conjunction with the operation manual included with this product. The manual includes general information and additional information pertaining to the operation, use of controls, alarms, indicators, cleaning, cautions, warnings, and notes that supplement the information contained within this video.